All right, I guess welcome everyone. Good morning. It's 8:30. Everyone's a bit, tired. So let's get started. This talks about Fedora IoT on 96 boards, and let's get right into it. Fedora on ARM. We have with us Peter Robinson, who I'd like to invite to talk a bit more about this.
Yes. So we support, or Fedora supports ARM and has done for a number of years. I first started working on the ARM v5 Fedora instance about 9 years ago, and then was actively involved in the floating point v7 bootstrap, and later on, before, or very, very early in the ARM64 ecosystem, we did the ARM64 bootstrap at a time when we were running everything on the ARM emulator, and it could take anything up to 3 weeks to build Qt or GCC or something like that. And it wasn't unusual to get 6 or 7 days into a build to find it fails for some really random, bespoke reason, only to have to turn around and do it all over again. Fun times. These days, obviously, a hell of a lot has changed, and the ecosystem has grown widely, and you can get extremely cheap $10 or $15 single board computers that we run on. It seems to be that the speed at which the ARM stuff is growing is accelerating at a rapid scale. And it's fun and exciting to see things that were, I suppose, closed becoming quickly open, such as some of the reverse engineering process around Mali and such. And yeah, even 9 years later, it still astounds me at how quickly this ecosystem seems to evolve, and how quickly the hardware changes and moves, although some things not quite as fast as I would like. Everything still seems to be very focused around Cortex A53s, Cortex A7s, and related sort of lower end stuff. So it's quite exciting to see some of the higher end newer cores come available around things like Hikey 960 and various bits and pieces like that. Also very excited around some of the FPGA and offload and machine learning stuff that's coming along, although again that seems to be a little bit like some of the GPU stuff was a few years ago, very closed, very proprietary. So it'll be interesting to see how some of that ecosystem grows. And it will be nice to see a bunch of sort of some of the neural processor related stuff, seeing some open tool chains to enable that to be sort of more widely available, I think. So yeah, we run on a wide variety of hardware. In the early ARM v7 stuff, every device pretty much needed its own kernel. Fedora was the first device to use what was known as the multi-platform kernel, and some of the crew at Linaro that led that effort were, I suspect at the time, widely sick of dealing with me and my problems. But at the same time, I suspect also quite excited to see a distro adopt it so quickly. And now we produce a single image in that one image of, say, a desktop environment can run across anything up to 100 boards, across a dozen different SoCs, and we have ARM image installer, which is a very rudimentary bash script I smashed together to make it easier, and it just seems to have grown. But you know, it's kind of fun where you get emails or pings on IRC say, oh, I just ran it against this board, it wasn't in the list, here's a patch, and it just works. And you know, different people in the ecosystem, oh, I'm running it across these 100 devices and it all just works. And it's like, wow, I haven't even heard of that device. And so, you know, I think Fedora shits in the range of a few hundred device trees for devices, and it's amazing the time it just works. Big, big change to what only seems like yesterday, where we supported, I think, the Panda board and one or two others. So the difference in the ecosystem is just astounding.
Yeah, and
What are we doing for the next slide?
I don't know. Yeah, so of course 96 boards on there. Peter just talked about how many other boards are supported. That's kind of the official list.
Yeah, so that's the official range of SoCs. And I mean, it's always growing. I don't see, well, the high silicon stuff is around the 96 boards. I believe that Ultra 96, so the Xilinx one should boot. The last time I had time to test it, it was very rudimentary in that it supported MMC and a few other bits and pieces. Part of the issue I have is that the 96 boards crew go, here's another board, here's another board, here's another board. And they pile up. And yeah, we only have so many hours in the day. So in that regard, I try to do it in such a way these days where it's like it's useful for the Fedora crew to have a board to be able to test, but if the vendors or the people producing the boards actually want to drive the Fedora stuff and do the testing so that the Fedora crew can focus on core stuff like kernel rebases and stuff like that, because you know, having 200-300 devices across a handful of people's desks just doesn't scale.
Yeah, so coming on to Fedora OSTree, and this will then tie up to Fedora IoT. Yeah, so I mean.
Yeah, so OSTree is a interesting technology. It's basically Git for file systems, and from an IoT perspective, like it's interesting chatting to the team that is in charge of the OSTree stuff. Red Hat had a product that was called Atomic, which had a bunch of technology, and then there was a third-party company called CoreOS that produced a distribution called Container Linux. And so we now have Fedora CoreOS, which is basically smashing those two together. And basically, the Fedora and what will ultimately be Red Hat CoreOS is basically taking the best of breeds of those two projects, merging them together and coming up with a super project. Speaking with the original, or the OSTree lead, he always saw it as a data center technology. I've always seen it as an IoT technology that they're trying to use in the data center. It's basically Git for operating systems. It's less flexible than a traditional distro because you get a set of packages and then you layer extra stuff on top. The advantage of it is that you can rebase to a newer release. You upgrade, roll back, so you can put a set of constraints. And last year we did a Google Summer of Code project, and out of that was a project called Green Boot. And so as the system boots up, it can test that the image was applied. If it doesn't get beyond, say, the grub and the kernel doesn't boot, you can trigger a watchdog and it will roll it back automatically. And so it's like a Git rebase to a new one. If it doesn't work, it rolls back. So the theory is that you should never get into a situation that you have an unbootable device. So for devices on the edge that may be inaccessible, you know, if you push out an update to thousands of devices and it doesn't work, you shouldn't end up with thousands of bricks. I was on site at a customer and they used the term truck roll. If we have to roll a truck to fix a problem, it's expensive. So basically, and so that's what the technology that Fedora IoT is based on. And the intention then, rather than so much layering packages, is to use container technology, so cryo and that sort of stuff, to be able to run applications in non-root constrained environments, so that if you have a rogue application, it doesn't affect the underlying device or the devices around it. And then because we're a new variant of Fedora, we also don't have a lot of the legacy installed base. So Fedora 30, we don't ship anything at all to do with System 5. And I finally managed to expunge the remnants of that 15 or so releases after Fedora switched over to Systemd by default. And we use SE Linux, setcomp, various kernel bits and pieces to slowly bolt down more and more to restrict basically the sort of, and make hopefully more secure the OS. So it's quite a small team at the moment. Got a couple of interesting customers that are playing around with it, and it seems to be just growing and picking up more and more speed, which as the lead of that project in Red Hat is sort of quite astounding, because it's interesting to keep up. There's some other sort of related OSTree projects within Fedora as well. Fedora Silverblue is a similar sort of, using the same technology on the desktop, and they use OCI Flatpaks for the same sort of graphical technology, so you end up with an immutable desktop. So yeah.
Yeah, so I tried out OSTree and some of my thoughts, but I just tried out on my workstation, so on a VM. So all the applications are containerized. You don't have to like run a VM for each app, so it just installs using RPM OSTree install command, and you have VM-like isolation using SE Linux. If you have install or an update that breaks, you can, like using grub, you can revert back to the previous install or configuration. The only one issue I do have of it, like using as a workstation, is that after each and every single package you install, you have to reboot for it to apply that. There is some live deploy features, but that's experimental, and most apps, desktop apps, are anyways using Flatpak.
Yeah, as Sahar says, like any of the upgrades, so if you apply a series of library upgrades for security or whatever, you need to reboot, and that's sort of like part of the Git, or the ability to upgrade, roll back. If you deploy a new version of a container, you can restart the container, obviously, without restarting the entire OS.
So finally, on the Fedora IoT side of things,
I think we've covered a bunch of this. It's a good thing I went through the slides first thing this morning.
Alright, so Fedora and 96Boards, we started communicating a couple of years back around San Francisco Connect, I think.
Yeah, so the 96Boards and Fedora crew, we first sat down in Budapest, and we'd never really had much to do with 96Boards. The original Pikey and Dragonboard 410 had come out, and they didn't really work in Fedora. And I sat down with Robert and Yang at the time, and we had a relatively frank and open discussion, I remember. And the relationship's grown ever since. And I speak to these guys probably on a daily basis. And, you know, it's fantastic being able to work with, you know, the team that deal with it. And the Fedora IoT support for the 96Boards is fairly early on, but the whole Fedora IoT project is also fairly early on. And we support a small selection of boards, and, you know, enhancements around that is growing all the time.
So yeah, so some of the current goals that we want to achieve maybe this year or until next Connect or sometime is to add new boards, of course, but we have been releasing them at quite a great rate. So and improve support for existing boards. Some of our boards boot, but they sometimes you have to just go into the UEFI shell or boot, and sometimes you have to install U-boot separately. So just, you know, improve overall. And on the MRE and UPM support side of things, I think MRE is mostly working. UPM, there's some build issue that was.
Yeah, I mean.
Piece.
Yeah, I don't remember exactly. It's been a while since I looked at that.
So we'll work towards that. Tested on various boot. I've already tested on Dragonboard 410C on Fedora 29, and also test various UPM sensors. So once MRA and UPM is working, all the sensor support that there is should work.
Yeah, I mean the big thing with Fedora is that we run an upstream kernel, and we do occasionally pull some enablement patches in here and there, but they're fairly short-lived. So if the upstream support isn't fantastic for an SoC or a board or a set of sensors, the support in Fedora is about the same. The advantage we have is that the current Fedora stable releases are already on Linux 5. The development release is already got Linus's 5.1 RC3 in it, and so we move and rebase very quickly. There's pros and cons to that, because occasionally we'll get a regression and random maintainers in the kernel get random emails from me going, it's broken, help! But, you know, if the board isn't supported upstream, if the device tree for that board isn't upstream, it will quite often not boot. In the Fedora IoT space, we're starting to push eBBR already, so we use firmware provided device trees to boot the device, and so if the support that isn't there in U-boot or Tianocore or whatever the firmware the board supports, it can be a little bit interesting as well. Part of that, the OSTree stuff I forgot to mention, the vast majority of the root file system is read-only to add an extra layer of security. And so while we have the device trees from the kernel there, it becomes a little bit interesting sort of gluing it in so Grub can basically find it because of the way that OSTree treats the underlying file system, hence the reason we went for the firmware provided device tree, which is part of the eBBR standard.
Yeah, so I think that also ties into the future goals of enable board vendors to support Fedora at launch. Now there's two parts to it, either have eBBR and also ties into the 96Boards software compliance that Mani gave a talk on Monday about, which we also promote, having eBBR and upstream support at launch. So with those two things given, I mean, your board should just boot. So that's kind of the requirement to boot Fedora IoT at launch. And use Fedora as a default distro for as many boards as possible. That's necessary because even right now we are just using Linaro's Debian build for a lot of boards. A lot of boards just come with their own Yocto SDK or build root and stuff like that. So if we have like a standardized distro supported, it's easier for us to write guides. Most of the guides then end up being a common guide, and just some device specific stuff goes into the device specific documentation.
Yeah, and so basically I think the major story there is upstream. And if you need like firmware for device support or NVRAM for certain wireless chipsets, again, upstream into the Linux firmware, so it's supported out of the box.
On a bit of the user space side of things, I guess, or maybe a little bit into the kernel side, we want to get started with IoT specific hardware testing, which then becomes ZigBee, Z-Wave, and LORA gateway. We have some shortlisted hardware there, so as and when we get the time. And
yeah, I mean, some of the wireless standards are quite interesting. I clearly forgot to put Bluetooth and Bluetooth Mesh on there. I've worked closely, and some of the 96Boards IoT edition stuff runs on Zephyr. I'd like to get more time to be able to sort of use things like Zephyr as an offload for things like Bluetooth Mesh, as sort of mezzanines and things like that. In Fedora itself, we tend to go for more open standards. So ZigBee is a little bit iffy because most of the ZigBee stacks run on the actual devices themselves, and their interfaces are a little bit interesting. Personally, I'm more focused on enterprise, industrial, smart city sort of stuff, because, I mean, I should have mentioned this at the beginning, my job is IoT at Red Hat, and most of our customers tend to be more in the sort of industrial, enterprisey sort of space. We have a huge amount of interest in the community around home automation, and there's a number of different projects there that we're looking at running in containers on top of that. And they obviously, because of home automation, support in particular the Z-Wave, ZigBee, those sort of standards. But yeah, it's a lot of the support for those sort of things is purely about time and interest. If people are interested in supporting them, they tend to come along and scratch an itch and assist, and we sort of scale it out like that.
Yeah, so I was supposed to present a demo, but I think we are kind of out of time. But on Demo Friday, I'll have a project running Dragonboard 410C on Fedora 29, and it's like a social media ticket kind of a thing.
And looking at the clock, while we don't have enough time to do the demo, we certainly have a few minutes for questions, and I have a separate microphone. So does anyone have any questions? Yes.
You talked about working, on industry, smart city, or applications like that. When we have an application to run on the Fedora IoT, and we want to get it in the hands of ODM so they can see what kind of products they can build all the way through the application stack. Where is that outreach occurring? Is that just like the ODMs figure out it's available, or how do we tackle some of these smart home situations where the people manufacturing and building the end products can know that this is available?
So we now have, as of a week, 10 days ago, a landing site, iot.fedoraproject.org, and that links to releases, getting started docs, and bits and pieces like that. In terms of development and that style of engagement, we have a number of channels. I'm PB Robinson at all the various different, so PB Robinson at Red Hat, PB Robinson at Gmail, PB Robinson at fedoraproject.org, same on IRC. I'm randomly on the Discord channel for 96Boards. and they will, it bounces when or my email pings when I get reference there. So from that perspective, we're still growing around that level of engagement just simply because of the resources available to us. Within Red Hat, it's a pretty small team that are sort of loosely coupled across a number of different parts of the Red Hat organization. And so we're certainly getting to the point around that. But to date, we've been focused on getting core functionality available so people can actually test in that regard.
In this next year, in 2019, do you think you'd be ready for commercial product to be deploying with Fedora IoT?
Yes. Within Red Hat, I'm actually doing and I can't quite mention the name yet, but I'm working on 2 prototype customers, and they're looking to deploy in their space in the tens of thousands, hundreds of thousands, and one seems to think they can get into the tens of millions of endpoints by the end of next year. So we're looking at certainly how we can deal with that and scale up. Again, it just comes down to time and resources. But the nice thing, and my remit when I started working on this and was given the explicit role to work on this within Red Hat, is go and do it in Fedora because it's all open, it's all there publicly. We don't have to have NDAs or anything like that, and so it becomes an open discussion.
Yeah, I have to leave for another session, so yeah.
Which session are you going to, Sahaj? What is it?
The Arm Duck session. So
and we'll be around for the rest of the week, so do come and speak to either us or Robert. And Robert doesn't really have his voice at the moment, so it's probably the perfect time to speak to him.